So today we're shifting. We're shifting from surface area, which is how much an object covered. We're shifting from the surface area to volume. Okay. Volume is how much space is inside of a shape. Right? Volume is what you guys are probably more used to. So if you think about the volume of like a bottle of soda, you don't care how much stuff it took to make the container. You care about how much soda is in the middle, right? Like a soup can, you don't care how much metal was used to make the soup can. You care about how much soup's in the middle. So today we're going to shift to volume, which I think is easier to understand. All right. Today we're going to talk about prisms and cylinders. Remember, prisms are any 3D shape. They have to be all polygons, so no circles, no curved lines. And there has to be, the bases have to be congruent, so the top and the bottom have to be the same. So like I just said, volume, it's up to you guys. You probably don't need it. Volume of a solid is the number of cubic units contained in the interior. We talked about, so far, we've talked about meters. So if I said I don't know how many meters I am tall. If I say I'm 6 feet tall, that's great. We talked about area, which is surface area. So like this is 36 inches squared. Now we're going to talk about volume, and it's going to be units cubed, okay? So volume is always given in units cubed. All right? So squared is area, cubed is volume. Whenever you're in doubt for the volume, just think about how much water can this shape hold. How much water would fit into it, okay? Volume of a prism is very easy. Remember that the top and the bottom are equal to each other. So the volume of a prism, if you think about a ream of paper, you know what I mean by ream? A ream, which I forgot to pick up. A ream of paper is like one little packet of paper, so 500 feet. If I'm looking at a prism, for example, this brand new textbook, can we all view this as a prism? This piece here? Yeah. If we take the base, which is 1 6 sheet of paper, and just stack them all on top of each other, see how these are all just very small bases, right? Together they'll all get the entire shape, right? The amount inside. So the volume is equal to the base, which here is the green part, times, we need to do it the number of times there are. Well, in this case, it's going to be the height. So the volume of a prism is the base times the height. Right? Very, very easy. The base can be any shape. It could be a rectangle, could be a triangle, could be a trapezoid, right? The height is the vertical height of whatever it is, right? Yes, ma'am? Length times width times height? Yeah. You're thinking of, that's a great question. You're thinking this is the length, this is the width, because you may have learned length times width times height for the area of the prism. Well, this works because what is the area of the base? It's a what shape? Rectangle. What's the formula for a rectangle? So this base is going to become length times width times the height. There's your volume is equal to length times width times height. Did they ever give you the area of the base? Perhaps. The reason I am giving you this one is because so far you've probably only dealt with prisms that are rectangular. Right? This only works for rectangle bases. Today we're going to talk about like a trapezoid base, in which case this formula no longer works. So the reason I'm doing this one more generally is that the base can change. So for example, a triangular prism. Okay? Whoops. Which leads me into the first problem. The formula you gave me, like with height, wouldn't work here because it's no longer a rectangle on the bottom. So if I'm the volume of the right trapezoidal prism, right means that it's going straight up and down. There are other prisms that are called oblique. You know where oblique is used in your body? Ever heard that word? No? There's a muscle called an oblique. You know where it is? Yeah, it's right here in your abs. It's your side of your ab muscles. So oblique means the sides. So slants, okay? So an oblique prism is actually a slant to the side. We can have those as well, but we're not going to talk about them. So right means it's going straight up. All right? It's perpendicular to the base. Trapezoidal tells you about the base. So the trapezoid is going to be your base. And the prism means that the base is going to be the same. So, area of a prism is equal to what? Base times height. So we need to find the area of my base. Well, my base is what shape here? What's the formula for a trapezoid? Half B1 plus times H, which is the? Okay. Now this is going to get confusing because here we're going to talk about the base of the prism, capital B. We also have the base of the trapezoid, which is the lowercase b, okay? So the area of the base, capital B, is 1/2. What is the one of my bases? 14. What's my other base?
3.
Not 3. 3 is the height. The 6 here is going to be the same as this distance here. So you see the base is 14 and this is 6. The 3 is the height. Okay? So it's 14 plus 6 times the height of 3. Carlos? So confusing also because we have 2 different heights. Alright? So let me redraw this. This may help. So far we're only talking about the trapezoid. So there's 14, 6, 3. Okay, does that help? So you're correct. There's 2 H's. One is the height for the prism. One is the height for the trapezoid. All right. So trapezoid only here. So the base is equal to 1/2 of 20 times 3. Half of 20 is times 3. So the base is equal to 30. What would the units be on the base? Centimeters squared. Very good. And then we plug it over here. The area is equal to the base, which is 30 centimeters squared, times the height. What's the height? Now we're talking about the prism here. 5 centimeters. So the area is equal to 30 times 5. 150 centimeters cubed. Notice that we have 2 centimeters here, 1 centimeter here, so we get the centimeters cubed. Okay, Carlos?
You know what I mean?
I certainly do. Guys, you're supposed to correct me a long time ago.
Yeah, I was so confused. What?
I'm sorry. Whoops. I get very confused because you guys are ahead of my other classes, and I just spent 55 minutes talking about area, and then you guys come in, and I have to switch my brain. I haven't quite switched yet. Okay? Thank you. Volume. So the volume equals the base times height. Right. Any questions? Concerns? Pretty straightforward. Find the area of the base. We're going to do a few ones that are harder than this, but that's all you got to do. Find the base, multiply by the height. Right? Volume of a prism. Okay. Some further ones. Just we got to talk about a cube. A cube has, what are the sides of a cube look like? Squares. So a cube, you guys probably already know this, but I just want to make sure, has side lengths of x. Find the formula for the volume of a cube. This is a special case. Well, the volume is the base times the height, correct? What's the base here?
X squared.
X squared. Why? See the base right here? See how it's x times x? So the volume is equal to the base, which is x squared, times the height, which is also x. So the volume of any cube is equal to x cubed, which is why it's called a cube. Isn't that kind of nice?
This only works for cubes.
Only works for cubes. It's called a cube because the volume is x cubed. Why is a square called a square? Because the area is x squared. Alright? Alright? So the volume of a cube is 90 cubic inches. Find the length of one of its edges. Alright? So the volume is equal to 90 inches cubed. And we know that it's a cube, so it's got to be equal to x cubed. How do I solve for x in that case? So if we divide both sides by 3, it would be 3x equals 90. But we don't have 3x equals 90. Hello? I want to solve for x, yeah. Yeah, it's called the cube root. So instead of the square root, we take the cube root. So if I have 90 equals x to the third, to get rid of this exponent, I need to take the cube root of both sides. Right? That says what number times itself 3 times is going to give me 90. Right? Now, I meant to give you calculators, but fortunately seniors are using them for their exams. But I can show you how to do that on your calculator. Hopefully you'll remember. Nope, not that one. Sorry. Yeah, so something in between 4 and 5 you can estimate, right? Because 4 cubed is going to be 64, and 5 cubed is going to be 125, so we know it's got to be between those. It's going to be roughly something almost halfway in between those, I think. Maybe a little less. So the way you do this, can you guys see that?
Yeah.
All right. On your calculator, if you go to this math menu, it brings up a bunch of stuff. One of the things here is the cube root. So here's cubed, or if you want it. So if you wanted to do like 6 cubed, you could type that in. Here is the cube root. So if I type in the cube root of 90, close my parentheses, I went to the math menu, and then hit enter. It's 4.48, so it's roughly exactly in between 4 and 5. So 4.48 times itself 3 times will give me roughly 90. Let's prove it. 4.48 times 4.48 times 4.48. Is my answer going to be under or above 90? Under, because I rounded down, right? But pretty darn close. Right? One more thing before I let you go. The other thing you can do is instead of taking the cube root, let's say I want to take the 5th root. Such things exist. We won't really get to them, but I just want to point this out to you. If you want to take the 5th root, notice that when you go to math, there's this one with the x. That means whatever root I tell you. Okay? The problem is you have to do it first. So if I want to take the 5th root of a number, I go 5, then I hit this little button, which means that the 5 is going to go up here. So it's saying I want the 5th root of, let's do, I don't know, 32. So what times itself 5 times is going to give me 32? Well, that answer is 2. Okay, so you can do roots higher than squared, and you can do higher than cubed. Carlos? The number up here in the small number is called the index. It tells you how many times we want it to multiply to get the other number. All right? So, make sense? I'll remind you of that when we get some calculators. All right, the volume of a cylinder. The volume of a cylinder, also very, very easy. You can imagine a cylinder as a prism. Okay? It's not. But you can imagine it as a cylinder as a prism. What is the volume for a prism? Base times the height. Right? Same thing. If you have a bunch of circles all stacked on top of each other, you just got to find the area of the bottom one and then multiply by how tall it is. Well, we know the formula for the base for a circle. It's pi r squared. So the volume of a circle is pi r squared h, because this base became pi r squared. Sorry, the volume of a cylinder, not the volume of a circle. Does that make sense? Yeah. Easy enough? Because my base now is not a rectangle, my base is a circle. What's the area of a circle? Pi r squared. So it's the same type of deal, just now that the bottom is a circle.
So does it always go with like the area of the shape?
What do you mean by the area of the shape?
Because like prism one, when we did like we did for the base.
That's quiet, please. Correct. So the base part is always the area of the base. So it's the area of the base times the height of the 3D shape, whatever it is. Okay. So pretty simple. Find the volume of the cylinder. It looks like a sardine can, maybe. The volume of the cylinder is, what is it?
Pi r squared times height.
Pi r squared times the height. Super easy. All you got to do is plug in your numbers. So it's going to be pi. What's r?
39.
9 squared. What's the height? 6. So you get the volume is equal to pi. What's 9 squared? 81 times 6. 9 times 8 is 48. 1 times 6 is 6. So you get 486 pi. What are my units? Feet cubed. Good.
Oh wait, so you never simplify the pi? You just keep it in pi form?
Either one's fine. Remember how we did our test on area? Since I don't have a calculator, I'm going to leave it in that form. I do. I will accept either one. If on your test I may, on your test you just took, I told you I want it in this form. So that's what I would do. Okay. I would say I want it in terms of pi, or I want a decimal or something like that. Okay. All right. So now we got some thinkers. That's all we have to do. The basic stuff's easy, but you can make these problems pretty hard. So first, if two solids have the same surface area, do they have the same volume?
Yes.
If two solids have the same surface area, do they have the same volume?
No. Because like with surface area, you like multiply like each base, right?
Well, you add each base.
Yeah, And then with area, you just do the base times the height, so it won't be like the exact same number, even though they have the same surface area. I mean, yeah, they won't have the same volume if they have the same surface area. Like it won't work out that way because you're not using the same numbers.
Okay. Carlos?
I don't know if it'd be the same, but it does sound like it'll be proportional.
They'll be proportional. What do you mean by proportional?
How smart do you have a big, the bigger it gets, the bigger the volume gets.
Correct, but the surface area would also change. So they do get proportionally bigger. Remember I showed you that, how the perimeter had a ratio and the area was the ratio squared? The volume increases by the ratio cubed. Okay? Okay.
I think it would be the same volume because if you had like two containers and they were like different shapes at the same surface area, that means they have like on the same side outside.
So you said, say that again?
Like two containers, if they had the same surface area, even if they were different shapes, they would still have the same area around it.
Right.
So I think it would follow the same.
Okay. Alright.
Every time.
The same? Sir?
I think it wouldn't because the surface area is like around it, up and down, and side to side. And volume means like how much is on the inside.
Okay. So you're saying because they're very different things, that couldn't be true. Right? Okay. Carlos?
I think that the surface area is units where volume is
saying it's a volume. You're saying that if two things have the same exact surface area, their volume would be greater, obviously, but then the volume would be the same. Not that the surface area is equal to volume.
So how can we test this? What do you mean by do it? Very rephrase. What do you mean by how can we do it? Okay, so you did a cube. How big was each side on your cube? 6? So what was the volume of this cube? 216. What was the surface area of this cube? Yes, it is. Because the surface area is all the spaces. The front face is going to be 36, right? Because 6 by 6. How many sides are there on a cube?
4.
So it's actually going to be 36 times 6. You forgot the other two that aren't shown. All right? So it's going to be 36 times 6, so it's going to be 216 again. All right? Now that's just a coincidence because you chose 6 as your side length. But we need to compare it to another solid with the same surface area. Right? So can anybody come up with another solid that's not a cube like this that has the same surface area? You can use a prism. Rectangle is probably the easiest. So I want something that has a surface area of 216, but it's not a cube. So you need to compare it to one. Yes, ma'am? For the side lengths?
Yeah.
So you need 2, 3, and you need another one. So you need the length, the width, and the height.
1.
You could, but then your surface area would not be 216. So we want to come up with 3 numbers that will have the surface area as 216. Pardon? 2 and 18, you need another one, though. Because you need a length, a width, and a height. All right?
I got the volume, I guess, to be in 216. It was the length is, well, the base is 6, it's 23, and the height is 36.
That's fine, but that's not what we need to check. We're checking 2 solids that have the same surface area.
Wouldn't it have 2 surface area?
It would not. You said what were your numbers?
2, 3, and 36.
2, 3, 36. Okay. 2, 3, 36. Nope. That would not be the same. So let's see if we can come up with one. We know it's going to be a prism. Alright? We know it's going to be a prism. The surface area for a prism, okay? In general, if this is my length, this is my width, and this is my height. Length, width, and height. We have, yeah. Whoa. So there's my net of my prism. Which one, the top or the bottom? Bottom is a really ugly prism. Alright.
I don't know if it's supposed to be like a sentence, like triangle,
No, it's supposed to be a box. Okay. Now, the surface area, we have 2 of these, right? We have 2 of these, and we have 2 of these pieces. Does that make sense? So it's going to be 2 times, well, the front's going to be the length times the width, doesn't really matter, plus 2 times the height times the length, plus 2 times the, which one have I not done? The width times the height. All right, that will give me all 6 sides. Pardon?
Would it be wrong?
9, 4, and 18, I think is going to be too big. Alright? So we just got to pick some numbers here that work. So let's see. Let's pick some values for the length and the width, and let's just find out what the height has to be, right? If we pick two of them, can we figure out whatever the height has to be? Because we know that the surface area we want is what? 216. So 216 equals, what do you want to pick for the length and the width? 2 and 3? So length is 2, width is 3. So let's plug it in. Length is 2, width is 3. 2 times 3 is 6 times 2. So this is 12. Plus, here we have the length is 2 times 2 is going to be 4h. You okay with that? Plus, the width is 3 times 2 is 6h. So I get 216 is equal to 12 plus 10h, which means that we're just going to have a super tall prism, okay? So if we solve this, we get minus 12, we get 2204 equals 10h. Divide both sides by 10, so h is equal to 20.4. Does that make sense here? Okay, this is going to have the same exact surface area as my cube. It's going to look really different. It's going to be a really, really tall box, really skinny, tall box, like something you might like store wrapping paper in. Okay, it's going to be like a small, skinny tube, a tube box, not a tube though. I think, yeah, a really tall rectangular box, right? We know the height. This is a special case. This is a special case of. Whoops. One of these guys. Length, width, height, because it's a rectangle on the bottom. So if we go back to our problem, we know the volume of this one. Let me use a different color. The volume is equal to the base times the height. Are we all right with that? So the volume is, what's my base here? It's the length times the, no, the base. The base is that little rectangle on the bottom, so it's 2 times 3. What's my height? 20.4. What's my volume? 122.4. So, does that answer our question? Does that answer our question?
No.
So our answer is, if two solids have the same surface area, do they have the same volume? No, not necessarily. Could they? Yes, but they would just be different orientations of the same shape. So for example, we could have 2, 3, 20.4. It could also be 3, 2, 20.4, or 20.4, 2, 3, all right? Just different ways to look at the same shape. It would be as if you rotated it. 1 second. The cool thing about this problem, guys, when you get to calculus, you'll do problems like this. They're called optimization. They're how can we optimize the amount of volume, in this case, per the amount of material we use, right? So a perfect example is packaging. You want to put as much cereal into a box without using as much cardboard, right? Because cardboard costs money. Does that make sense? The perfect prism is actually a cube. You will fit the most amount of stuff into a cube per the amount of material that you have to cover it with. Does that make sense? So if you're trying to hold the most stuff and you have a fixed amount of cardboard, you should make a cube. Right? Because that's the next thing I was leaning towards. If it makes the most sense to put your cereal in a cube, why don't people put them in cubes? harder to pour. Great answer, right? If you open the top and it's a cube. I'm thinking of a different reason. That's pretty good. What's another reason you wouldn't put it in a cube? They can make a smaller cube though. Right. So picture this, right? Picture this. You're walking down the grocery store. Tall box, tall box, tall box, cube. Tall box, tall box, tall box. Wouldn't that look a lot smaller?
Yeah.
Because if you think about the shelves, you don't usually look at how deep they go. You just look at the front of them, right? And that limits the amount of marketing space they can have, right? They can't put their giant, Tony the Tiger on the front, okay? So sometimes it's not always up to optimization, right? In this case, the cube would get the most cereal, but sometimes it's not always the best option, right? You have to think about things like pouring it, and you have to think about things like, well, our cereal is going to look ridiculous if we put it next to all these other cereals, right? So other variables come into play. They may not be mathematical. Like one is just, can you use it? And the other one is, well, how's it going to look? So sometimes it's not always about the math. Yep?
I have a question.
Uh-huh.
Okay, so now they're making two boxes, like, they're selling like two boxes of like cash consider.
Sure.
And then there's one is like a big, more of a cube, and then a rectangle, and two bags inside of the box.
Uh-huh.
That one would be better than the two.
They're probably going to be the same, but I can't tell you without actually seeing it. Because the other thing about cereals is technically it's not filled up in the box. Technically, there's a bag inside of it. So.
The bag is filled up all the way.
Correct. Yep. You may. All right. No, I'll save it for later. Find the volume of that.
Oh, don't you have to cut it, like get the cube and then
So which one would be the whole thing
Italy is like the long.
How many units?
If
You're writing down numbers. You're trying too hard. Arden?
Oh, because you just cut off the top cube, and the top cube would be one by one by one, and then you have the bottom cube, and then, the bottom rectangular prism, it would be 3 by 2 by 1.
So how many cubes would fit in the bottom one? Think of 1 unit cubes, 1 by 1 by 1. One would fit up here, right? How many would fit into the bottom part? Well, it's 1 deep. It's only 1 deep though, so it's only going to be a solid, like a wall of them. 3 across, 2 high. So how many are going to fit in the bottom? 6. How many total? 7. 7 units cubed. All right. So you can split them up.
Wait, that's why
Think of a very small cube. A 1 by 1 by 1 cube. In the top, you can fit 1 in there, right? In the bottom, it's only 1 deep, so there's not going to be one behind it. You got to build one. Think of building a wall, 2 cubes high and 3 cubes across. So there'll be 6 cubes down there plus 1 on top. Think of like using little building blocks and building the shape.
Oh my god.
All right. Find the volume of the prism.
Which one?
This shape is basically a triangle, and then there's been a square cut out of it. See the square cut out of it? So you've got a triangular prism, and the square prism has been cut out of it. Yeah? Carlos?
The area of the shape of the
The volume of the shape. Front? Doesn't give it to you. Good question. Artie?
Leave the flat height or put height?
Depends on which way you're doing it. What's the volume of a prism? Base times height. Is my base on the bottom?
No, yeah, no. The top.
My base is the thing that's facing you, right? Because remember, the bases have to be the same. If I chose the bottom, it doesn't have the matching piece on top. So it's a triangular prism minus the stuff that's cut out. Okay? So the base is here and then the back. What's the height?
The height is going to be 6.
Height's going to be 6 for the whole shape. You see how this is oriented differently? It's laying on its side, so the base is in the front and the back, and the height is between it. So if we know the height, the only thing left to find is the... We have the height, we need to find the base. Does that make sense? So the base looks like this. That should look familiar to the last chapter. How would I find that shaded part? Yeah. It's the area of the triangle minus the area of the square. Does that make sense, guys? Okay. Karan asked a great question. He said, what's the height of the triangle? Well, we don't know. Karan, did you figure it out? How am I going to find it? Is it what? It is?
4.
That only works for right triangles, and that 3 actually points to the square, not to this triangle. So the 3 is talking about the side length of the square right here. Naomi? Yep. Find the area of the triangle, not prism, minus the area of the square. We need to find, in order to find the triangle, we need the height, though. How could I find the height of that triangle, Carlos?
How's that special?
It's equilateral to start with, so I would call that special.
So you know,
Well, it's going to be.
If it's equilateral, then the size of 10 is just cut it in half, and it'll be 5. It'll be 10, 5, and 7. Oh.
It's equilateral. So if we cut it in half, everybody's, whoops, that was supposed to be green. If you cut it in half, how much is the bottom, this little piece going to be?
5.
How's this, is this? And then my height then is my x. Everybody agree with that? Does that make sense?
That's the height for the square, the height for the triangle.
That's the height for the triangle. So we're taking the triangle, which was a 10, 10, 10. We're cutting it down the middle. This will leave me with a 5. This is still 10, and then this side is going to be my x. All right? Yes, ma'am?
When it's like this front part is on the bottom or on the top.
The front part is my base, but it doesn't have to be on the bottom or the top. Just has to be congruent to the back side. If that helps you to view it like that, if you flip it, that's fine.
So I thought it would be 6.
As the what? Okay, we're talking about the height of the triangle here, not the height of the whole prism. That's the h here. We're talking about the height for the triangle. Okay. Arden, did you get that height? Sorry. So the height here is 8.66. Ananta?
Which height is
Please.
the one for the
That's the 6. We haven't dealt with this. So far, we're only talking about the base right now. We haven't even touched the 6 yet. No, no, no. Guys, quiet, please. Trying to help your classmate. It's being rude. So the base is equal to the area of the triangle, which is, what's the area of a triangle? Half the base times the height. That's where the height we just found goes. Okay, there's 2 different heights. There's the height for the prism, which is the 6. And then there's the height for the triangle, which is the 8.66. So minus the area of the square, which is just the side squared. Okay. So the base area is 1/2. The base of the triangle is 10. The height of the triangle is 8.66 minus the area of the square. What's the side length to the square? So this will be 3 squared. Does that make sense? Because I dropped the altitude down, and I formed a smaller right triangle. 5, 10, and there's the x.
Okay, but where did you get the height from?
Use the Pythagorean theorem. Sorry, I didn't show you that. Or that's a 30, 60, 90 right triangle, special triangle. So either one of those. Arden did it at her desk, and we're almost out of time, so I just wrote it down. Okay. Arden, can you calculate that out?
Okay, you want just the base?
Just everything together, yeah.
That's gonna be 34.3.
34.3-ish. So 34.3 is the area of the base. Now the base here is that triangle minus the square, which is missing. Does that make sense?
No. Everything on both sides.
Yep. See how it cuts all the way through? Okay. So now the volume for the prism is the area of that base, which is just the front, the triangle minus the square, which is 34.3, times, what's the height of the prism? 6 times 6. Whoops, I don't know why I did that. So the volume of the prism will be what? 205.8. What are my units? Feet cubed. Remember, volume is always cubed, okay? So just to recap, volume is the base times the height. Be careful what your base is. The bases always have to be congruent, right? The base is not always the bottom. Find the area of the base. Well, this is what took us so long here. It was one of those complex shapes, so we had to do the area of the triangle minus the area of the square. In order to find the area of the triangle, we had to do another step. We needed to find the height. So we didn't know the height of the triangle. So we drew the line here, used the Pythagorean theorem, and found the height of the triangle. We plugged that number in with the base of the triangle, which was 10. Took half of it, and then we subtracted the size of the square, and they told us that one of the sides was 3, so minus 3 squared. We got the base for the whole shape, okay, for the prism. Then we plugged the base in, times it by the height for the entire prism. The height for the entire prism was 6, and we got our volume. Right? A lot of questions, a lot of steps, a lot of different formulas you have to use, but hopefully that made sense. Does that make sense?
Yep.
Okay. And that's it?
I don't know, what that, taken out, and then find the volume.
Correct. The next thing I was actually going to say is I meant to just said it. Please listen up. Perhaps another easier way you could do this, or it's about the same. You could find the volume, you could ignore the whole. Find the volume of the whole triangular prism, and then subtract the area of the square prism. Does that make sense?
Yeah.
So you could completely ignore the square from the start, find the area of the whole triangle prism, find the volume of the whole triangular prism, minus the volume of the whole square prism. Okay? That would be fine as well. Last question to leave you on. Which cylinder has the bigger volume? I asked the same question about the surface area. Which one has the bigger volume? I don't think we're going to have time. The bell's about to ring. However, I want you to think about it. Cylinder A has twice the height. Cylinder B has twice the radius. Arden? Twice the height? Maybe.
Are we doing all of it?
Yep, all of it. Should be pretty straightforward now. A few of them should be like 1-minute problems. Top. What picture is that? Katrina. Pretty scary, isn't it?
How are you supposed to do that? Was that?
What city? Yes.